Hello everyone, and welcome to this math day video on how to write the equation of a line of best fit from a scatter plot, and also to answer some questions about association, clustering, and outliers with respect to linear scatter plots. So I have here a scatter plot that's your exam score versus, number of classes missed, and 6 questions associated with this scatter plot. So let's look at the first one. It says to discuss any clustering and any outliers. Clustering, of course, is a group of points which is way more dense and put together than anywhere else on the graph. I would not say this graph has any strong clustering. You could talk about clustering as being strong or weak. I do see somewhat of a weak clustering here. Now, if this were just single dots outside of it, then it would be a much more strong cluster in comparison, but the whole graph is kind of clustery to begin with. So I would call this a weak cluster around this point right here. And for outliers, the only thing that I see that could possibly be an outlier is this point because it is far away from the rest of the trend of the data. There is a statistical method for calculating an outlier. We're not going to worry about that now. We're just going to go visual. So if you would say maybe this was kind of a weak outlier as opposed to a strong outlier, which would be a point like maybe over here or way, way, way up here. The further away, the more of an outlier classification it can be. So do remember when you're talking about clustering, you can use the words strong and weak to describe the difference between something that's barely fitting that definition and something that clearly fits that definition. For the association of the line, part 2, we would say that the line has a negative association. It's somewhat of a linear association because it does go down. So for the clustering, I'm going to say weak clustering around x equals 10. Normally we talk in terms of the domain or the x values for that clustering. And an outlier, a weak outlier around, I guess we could classify that point as about 19, I don't know, 8. If we're guesstimating the coordinates of that. You can also maybe circle it or highlight it. I just don't want to do that right now. Like if I were taking a quiz, I would circle this and write clustering. I would circle this and write outlier. But we're getting ready to do a line of best fit on this, and so I don't want to mess up the graph too much yet. Association of the line. A negative linear association because the points continue to decrease over the course of the graph. And if it were to have a slope, it would be a negative slope. Okay, the next part says to draw a line of best fit and explain why you picked it. We discussed in class how a line of best fit is a line in which you have about half the points above and about half the points below it. So I would say this was a decent line of best fit right here. If we calculate, I see about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points above it, and 1, 2, 3, 4, 5, 6, 7, 8 points below it. So this would be a somewhat of a linear pattern to the data through here. I don't have one of my nice see-through rulers, so in a pinch, now that I know where I'm going, I'm going to use the side of a sheet of paper to approximate my line of best fit. So we drew the line of best fit. Why did we pick it? It has about the same number of points on each side. That is why we picked it. There can be multiple decent lines of best fit, but of course, obviously, if we were to take a line and put it up here, there would be almost all the points below it and only 1 point above it. That would be a horrible line of best fit. Contrastly, if you were to put a line down here and we had just like almost no points below it and all the points above it, that would be a bad line. Anything kind of going through the middle of the dots is going to be a decent approximation. So the answer to the next question about the equation of the line of best fit is going to vary depending upon the coordinates that you pick. So it's going to be really, really important that you write down the coordinates. I don't have room on this piece of paper to find the equation of the line of best fit, so I am going to pull some scrap paper from below in order to work it out. And this is the part that I know you students are the most interested in seeing how to do. So I'm going to look at here, and I'm going to pick two coordinates that are really a good approximation of the graph. We don't have a grid on here like we do on our test in class. So I'm going to approximate the coordinates of that point. And, ooh, this is a pretty decent one. This point. This one is pretty clearly 20, 40. So I'll use that point to write my linear equation. And this one looks to be about, let's see, if this is 5, I'm going to say this is 4. And let's say this is about 95. So I have a decent set of coordinates to calculate my line width. We have been practicing this in class for several days, and we all know that the first thing you have to do is find the slope of the line, the rate of change. So here I'm going to do y2 minus y1, and remember, if it helps, you can label your coordinates as xy, xy. This is my first coordinate point, and this is my second coordinate point. They're merely references. So I do y2 minus y1, and then I'm going to do x2 minus x1. If I do 40 minus 95, I get negative 55, and 20 minus 4 is 16. We knew this was going to have a negative slope because the line is a falling line. So after I have a point and a slope, we can do the point-slope equation. M equals y minus a y coordinate over x minus an x coordinate. The slope is this point, this coordinate, this fraction right here, negative 55 over 16. And then I put in any point on the line. I have found the coordinates of 2 of them. I think I'll use this one. It's a little bit simpler, all multiples of 10. So the x is 20 and the y is 40. And so now this is my point-slope equation with a point and a slope. Beauty of this equation is I can cross-multiply and not have any decimals until I want or need them. I'm going to do 16 times y minus 40 and negative 55 times x minus 20. So now, after I have cross-multiplied, I will distribute. 16 times 40 is 640. Don't forget to fully distribute. And 20 times 55 is 1100. Negative times negative makes positive. Now, at this point, after I cross-multiplied and distributed, I have to make a choice if I'm going to write the line in standard form or if I'm going to write the line in slope-intercept form. If I look at the next questions, I'm going to be using it to calculate points. So I think I'll just go ahead and write the line in slope-intercept form, which means I'm going to solve it for y. So I'm going to add 640 to each side. Nice thing about this, again, no fractions until the very end. Negative 55x plus 1100 plus 640 is 1740. Now, in this case, since I'm giving exam scores and number of classes missed, I'm going to be rounding. I'm just going to go ahead and divide this all by 16 to solve it for y. So my slope and y-intercept will be as decimals, which are appropriate for this situation. 55 divided by 16, let's go to the nearest hundredth, negative 3.44x. And 1740 divided by 16 is about 108.75. So this is the equation where the input, if you'll look at the graph here, is the number of missed classes. That's the x, the input. And the y is the exam score that we can expect. So if we look at the slope, you could be asked to talk about the slope and its real world meaning. We would expect the slope as a decimal for every, if we look at the slope as a over 1, slope is change in y over change in x. So every time the change in y is negative 3.44, the change in x is positive 1. If we look at that in terms of the degree, for every single missed class, we can expect our exam score to go down about 3.5 points. That's what this is saying. And then it is based on the model. If you put in a 0 for x, meaning 0 missed classes, you can expect to get a 108 on the exam, which we could probably surmise is not possible unless there's a lot of extra credit. So this is the linear model for this equation. Y equals negative 3.44x plus 108.75. And you could be asked to explain what do the slope and what do the y-intercept mean in terms of the real world. So we'll write that down here just in case, even though it's not asked here. Decrease in 3.4 points on exam for every missed class. Missing no classes gives a 108.75% on the exam, which we all know that that's probably not a realistic way to use the model. Not only is it probably impossible to get more than 100% on the exam, we know that you could sit in every class, and if you do no work and don't pay attention, there's no way you're going to get 100% on the exam, let alone 109%. Next, find the expected exam score for a student who misses 0 classes. Oh, that's what they're asking here. And explain your answer as well as describe if it is interpolation or extrapolation. Okay, so we already know that this refers to the y-intercept. Because if you miss 0 classes, you're going to get the highest exam score. So if we take our equation and put in 0 for x, (3.44 times 0 is 0 plus 108.75 is 108.75%, which is impossible. The rest of it says, is it interpolation or extrapolation? We learned that interpolation is when you're using the equation model or the line model to predict something that's happening within the data that is already there. Extrapolation is when you go outside the data. Well, this data starts here. It starts about right here and ends about right here. And in this case, a y-intercept is certainly outside the data. So this is extrapolation. Next, for a student who scored 97% on the final exam, how many classes would you expect they missed according to your line of best fit? Okay, so they're asking us to do it according to the line, not according to the graph. Well, our input, or x, is the number of missed classes. Our y is the exam score. And they're saying we get a 97 for the exam score. So if y is the exam score, then y must be the 97. Plug in what you know, solve for what you don't. At the first one, we didn't know the exam score. We did know the number of missed classes. On this one, we know the exam score, and we're trying to figure out expected how many missed classes there could be. So I have to use inverse operations this time. So let's do the solving. 97 minus 108.75 is about negative 11.75 equals negative 3.44x. I divide both sides by negative 3.44. On my trusty calculator, I get x is approximately 3.415. So we're talking about 3.5 classes, which if you leave halfway through a class period, that is technically possible. So you could say essentially, you could say about 3.5 classes or between 3 and 4 classes. As long as you have the work to justify your answer, then you're okay. All right, so that is an example of how to use a scatter plot to find a line of best fit and to answer miscellaneous various questions. Next time, we will look at a different scatter plot about ice cream sales versus temperature.